It's math time with Heinz. It's math time with Heinz. Math time.
Hi everybody, welcome to lesson 1 here, where we're going to be starting our new unit on polynomials. So before we start with polynomials and talk about what those are, let's take a trip back to 5th grade and understand our base 10 number system. So what we need to understand is, what is 563? 563 is really 5 hundredths, 6 tens, and 3. 5 hundredths, 6 tens, and a 3. And our number system is base 10. What does that mean? Well, what is 100? 100 is really 10 squared. So over here, when I get to 3 thousands plus 8 hundredths plus 40, 4 tens, plus 2 ones, well, what is 1,000? 1,000 is really 10 to the third. So our number system, our place values, really correspond to that exponent. It's related to that 10 raised to some power. Plus 8 squared, plus 4 times 10. That's really 10 to the 1, but we don't write that 1. Plus 2. That's 10 to the 0, which we don't write. So that's how we can write it in this expanded powers of 10 form. 21,479. Well, I have 2 10,000s. I have 1,000. I have 4 hundredths. I have 7 tens, which is 70. And then I have 9 ones. So in kind of writing this out in terms of exponents, it's 2 times 10 to the 5th. That's a place value. There's a 2 in the 10 to the 5th place value. Plus 1 times, that's 10 to the 4th. 10 to the 4th. Plus 1 times 10 to the 3rd. Plus 4 times 10 squared. Plus 7 times 10 to the 1st. Plus 9. So what we're doing today is we're going to take our base 10 number system and think about it in terms algebraically and abstract it a little bit, make it a little bit more less defined. Instead of working with the base 10 number system, what if I work with a variable thrown in there? So let's rewrite 63,000 as a power of 10. Let's see if we can jump right to the end here. So it's 5. We're going to work backwards. Plus 3 times 10, plus 7 hundredths, 10 squared, plus 3 times 10 to the 3rd, plus 6 times 10 to the 4th, right? Every one of those numbers is filling a spot for a certain number of powers of 10. So instead of 10, let's write an x. Instead of 10, let's plug in an x. 6x to the 4th, plus 3x to the 3rd, plus 7x squared, plus 3x plus 5. So what we did is we took our base 10 number system, and what we just created here is called a polynomial. Polynomial. Poly means many, nomial means terms, many terms. There are many terms in this expression here. There's 1, 2, 3, 4, 5. There are 5 terms in this expression, and we can't combine those together because everybody belongs to a different place value. You can't add x and x squared together, just like we're not adding our hundredths and our tens together. They're not like terms, so we can't combine them. So a polynomial is any expression in this form: a number times x to a power, plus a number times x to a power, plus a number x to a power. Then sometimes you have your plain old x term, and then at the end you have that plain old number who doesn't have a variable. The exponents have to be positive and integers. So no negatives in your exponent. No negative exponents are allowed. So consider these expressions and let's talk about if they're polynomials. 4x squared, 8x, and 1, that's good to go. I've got numbers x to the power plus number x plus the plain old number. Good to go. Here, we're not good because you can't divide. Dividing by x is not allowed. That does not make me a polynomial. When I divide by x, that's not a polynomial. A polynomial is something that's nice. It's something that's nice just like this. There's nothing crazy going on here. Notice the variables in the exponent, these are exponential functions. These are exponential functions. X is the base. X is the base, not in the exponent. That's the problem there. This next one, I've got two problems. Square root is no good. Negative exponent, no good. These first two terms are good, and then it just goes down from there. 52 is a polynomial. It's a number. It's kind of right here. Everything else I don't have. I just have that plain old number. So any number is a polynomial. And again, we're going to get more comfortable working with polynomials as we go along. But this is kind of our standard way of looking at a polynomial here. And the way we write polynomials, we write them in standard form. Just like our place values, we go from the highest power down to the lowest power. We write our exponents in decreasing order. So consider this polynomial. Explain why it's not in standard form. Well, it's 2x squared, 5x to the third. This guy's got to be all the way in the front, minus x plus 8. So if I was to rewrite this, I need that 5x to the third out front, plus 2x squared, minus x plus 8. This is the order our polynomials go in. X to the third, x to the second, plain old x, because that's x to the 1, and then the plain old number. I got a lot of vocab here, a lot of vocab to talk about. The degree of a polynomial. This is a degree 3 polynomial. Why? It's the highest power. Whatever the highest power is, that is the degree. So here my biggest exponent is 3. This is a third degree polynomial. The leading coefficient. Well, we've heard the word coefficient before, but what makes it leading? Well, it's the coefficient of the term with the highest power. That's what makes it leading, is it's the coefficient of the term with the highest power. And we call it the leading coefficient because when it's in standard form, it's that number out front. Only if it's in standard form. You can't look at a polynomial and say the leading coefficient's 2. No, you have to double check and make sure you're in standard form and find that highest power, and that gives you your degree and your leading coefficient. Last vocab word here, that plain old number is called the constant. That plain old number stuck on at the end is called a constant. So the constant is just that plain number that's hanging out there. All right, write each of the following polynomials in standard form. So let's write them in standard form and see how we go from there. So we got to write these guys in order. So who is the highest power? Well, 5x to the third. Then comes the squared. Then comes the x. Then comes the number. So again, I went highest to lowest power. Degree, leading coefficient. Who's my degree? What's my highest power? My highest power is 3. My leading coefficient, who goes with that? 5. And my constant, the plain old number, 7. 7 is my constant term. It's the plain old number. That's all we're doing here is working with these polynomials. All right, this next one. Highest power, 9x to the fourth. Who comes after x to the fourth? Well, normally x to the third, but I have 0 of those, so I'm going to skip over that because I don't have any. After x to the third, x squared minus x squared plus 2x plus 1. Degree, leading coefficient, constant. So my degree, my highest power here is 4. My leading coefficient is 9, and my constant is 1. Well, this is a monomial here. Not a polynomial, it's a monomial. because there's only one term. Mono, like monotheism, monotheistic, there's one term here. So it is in standard form, so I don't even need to think about that. Degree is 2, leading coefficient, -4. The constant, though, what's the plain old number at the end? Well, 0. The constant's there, we just don't write it because it's plus 0. Bottom row here. Here we go. This one's tough because you got to make sure you keep the signs with the terms. You got to keep the signs with the terms. -5x² is the highest power, minus 2x, positive 3. Degree, 2, leading coefficient, -5, all from that first term. So this guy here is called a trinomial. Like a tricycle has 3 wheels, this polynomial has 3 terms. It's a trinomial. You're going to hear me say that word a whole lot. Trinomial. Trinomials have 3 terms. And finally here, highest power, x to the 9th, x to the 7th, x², and then x. That's standard form. That polynomial is written in standard form because the powers decrease. Degree, leading coefficient, constant. Degree, 9. Highest power is 9. Leading coefficient, what number's in front of that? A 1. Constant is a 0. Okay? So there's some good vocab there. Degree, leading coefficient, constant, trinomial, monomial. Hopefully you've heard these words before and they're coming back to your head. We're going to end by jumping to number 6 here. So again, our polynomials and the integers, our base 10 number system, are very closely related. So find the sum of 5, 2, 3 plus 2, 7, 1. Using the standard algorithm, we get 4, 9, 7. Because what we really did there is we said we have 5 hundredths, 2 tens, and a 3. And I'm adding that to 2 hundredths, 7 tens, plus 1. So when I combine these terms here, I just add them. 4, 9, 7. Notice, did I add those exponents? I didn't. I have 5 hundredths plus 2 hundredths gives me 7 hundredths. I have 2 tens plus 7 tens gives me 9 tens. So we don't touch the powers when we add. When we add polynomials, we just deal with the coefficients. When we find the sum, no exponents change. No exponents, we just play with the coefficients. So find the sum of 5x² plus 2x plus 3 added to 2x² plus 7x plus 1. So when I find this sum, I get 4, 2x and 7x is 9x, 5x², 2x², 7, they're still x squareds. I don't touch the exponents, I simply add the coefficients out front. So when we add and subtract, which we're going to deal with in the next lesson, you add the coefficients, you don't touch the exponents at all. All right, guys, that was lesson 1. I'll see you soon.